Hello, and welcome to the EWSS instructional video. The EWSS, or Electronic Warfare Scenario Simulator, is a simulated scenario environment that generates a stream of EW data. That is, we can select a platform in a scenario to receive all our calculated electromagnetic data and send it to other software in real time. This other software is usually simulated devices for the purposes of training or maybe mission rehearsal. In this EWSS instructional video, I'll show you how to create and edit a basic scenario containing platforms and emitters. I hope you'll find this software to be an easy and practical tool for scenario development. Okay, so what I've done here is bring up the EWSS in our Tech Demo app, and what I'm going to do is create a very basic scenario. And I'm going to do that by first zooming into a location in the world that has some interesting terrain. And let me zoom in a little bit more. I'm using the zoom box here, but there are multiple ways to actually zoom in. And okay, actually I want to move up a little bit. Up to here. Excellent. Okay, so what I'm going to do is first thing I need is a platform. So I'm going to go ahead and add a new platform. All emitters occur on platforms. A platform can be anything. In this case, it's going to be a simple fixed emplacement, but that will suffice for what we have here. You can tell there's a few basic pieces of information. The RCS, the persistent state just means it'll be saved. Receive reflections for radar effects, and terrain limited. That means it's going to stay on the surface of the ground because it's a fixed emplacement. Alright, and actually let me adjust the motion of it, the position of it actually. I'm going to move it over here a little bit, and you can see as I move, the altitude changes. That's because it's locked to the surface of the Earth, being a fixed emplacement. Also, you can see as I move my cursor around, you'll see the elevation and latitude, longitude changes, so that you know exactly where you are. And you'll also see the range bearing, and that range bearing is actually the range bearing from the selected platform to where my mouse cursor is. Alright, so that's platform 1. Let me create another platform. I'm going to add another new platform, and this one I want to be an aircraft, so I'm going to choose from several different types. But when I pick a fixed wing, for example, I then get all kinds of parameters that I can adjust to model the motion of that aircraft. In this case, it will try and follow these motion parameters even in waypoints when we set up waypoints, and I'll show you that in a minute. I'm going to go ahead and give this a speed so that we have a speed for the aircraft and a altitude. Let's make it 20,000. Okay, and platform 2, let's call this own ship. Okay, and we've got all the parameters we need, and what we need is an emitter. So let me go ahead and put an emitter on one of these platforms, and it's a relatively simple thing to do. Just click the platform. Again, I'm right-clicking to add a new emitter. When I add a new emitter, I get a bunch of basic parameters. I get an emitter, a mode, a beam, a signal. What we want to do here is first thing, let's go ahead and change the scan from steady to circular. Now I have a circular scan pattern. You can see that in the beam. Here's a view of the beam that's we've created with the scan pattern, and the scan pattern is a little fast. Let me slow it down. Search radar. Alright, so I've adjusted that. And another thing I can do is angle the beam up a little bit because it's a search radar. Also, this should be a fan beam, so let me go ahead and choose the beam width to be a little bit bigger, 45 degrees. Alright, so now we've got a 45-degree beam, and it's ready to go. Also, we have a signal at this is the pulse table right here, showing you the signals at 750 megahertz. I'll go ahead and make that 1250. The PRI or PRF, if you prefer, is available, and the pulse width is 4 microseconds and a count of 1. That means it'll produce one of these pulses and then wrap to the next one around. So to add another pulse, I'll just simply add another pulse there, and it makes a copy of the first one. And in this case, I'm going to set the count to 10. So it'll do 10 of these, and then what I'll do is I'll do this one at, say, 12:45, and it's a PRI of 800, and a pulse width of 2, and we'll do this for a count of 3. So what'll happen is it'll do 10 of these pulses, 3 of these pulses, and then go back and do 10 more, 3 more, ad infinitum. Alright, and we want this to actually turn on when we run the scenario. So what I'm going to do is I'm going to add a time event. And by adding a time event, I just select mode, and there's the time when I want it to turn on. That's fine, 0. And I'll go ahead and close that. And if I run this, we should get an emitter. Now what you're seeing here, let me back up for a second here. What you see here is, of course, the platform. You can see the beam width that I selected for this particular beam from the top-down view, and the unambiguous PRI range is the circle. And if this was a sector scanning emitter, for example, then it would go back and forth between a sector, and you would see the sector in blue lines as well. Alright, so now this scenario is running, playing. I can also pause it. Pausing it really just stops the platform motion. If you play, then it allows the platform motion to go on. Also allows the scenario time to go on. Alright, so let's see what our emitter looks like. I can go to this quick analysis view, and when the signal comes around, he picks it up, and now you can hear the audio. And I'm going to change the dynamic range a little bit to make the signal more prominent. And I can also change the time for this oscilloscope view that we've got. Alright, so that's a basic scenario that's very easy to create, and to create a much larger one, all you do really is more of the same. Alright, one other thing, let me go ahead and show you the waypoint system. I'll go ahead and stop this scenario, and I'm going to go to I'm going to add a waypoint for this ownership. Now that means that the ownership will now follow these points that I select. Right. So, by the way, all these platforms are full 6 degrees of freedom motion. So, and they're entirely governed by these motion parameters right here. So, for example, it will not accelerate. It will not go past this turn speed or this acceleration or this altitude. And in this case, it will try and follow the waypoints by autopilot, auto-navigate by time. You can have other options too for different reasons, which I'll go into in a future time. Alright, so the ownership is there. Let's take a look at the waypoint table. Now, the waypoint table here is showing me the altitude in mean sea level, and this is AGL. And it will show the heading changes and the speed. So let me go ahead. I'm going to speed this guy up on the second one. 50 and 500. And let's say 600. Alright. And you can see all these are airborne, so he's well above the ground here. Alright, so that's good. Now when I play, and actually I can see what time, it'll actually be at 2 minutes and 22 seconds when it gets to that waypoint. 3 minutes and 35 seconds when it gets to that one, and 4 minutes and 59 seconds when it gets to that one, assuming it can actually make these turns. If I were to slow down the parameters, the turn rate, for example, were too slow, it would not actually be able to make some of these waypoints. But that's alright, it'd do its best to try and get there. And if it couldn't get there when the time elapsed, it'll just go on to the next one. Alright, so I'm going to go ahead and play again, and the ownership is speeding up. I guess I left it at 0. And it's going now. I could wait for it to go the 2 minutes, but I think what I'm going to do is I'm going to go to the run control and go to time multiplier and speed it up a little bit. Also, I'm going to zoom in here so we can see what's going on. And at the same time, I'm going to do signal analysis. And I think we're going a little bit too fast for signal analysis to pick it up right now. So, run control, time, slow it down. Alright, there we go. Alright, so now we have the signals coming in. And if we zoom way in, you'll be able to see the own ship change its direction as it hits this waypoint. Okay, so as you can see, it's trying to make this turn. It's changing speed, changing heading, all in an attempt to get to this next waypoint. Alright, so that is a basic scenario. And to make a larger scenario, as I've said, you just make more of the same. And what I'm going to do now is I'm just going to show you a bit more in detail because there's a lot more to this. So I'm going to start with a fresh scenario to do that. Alright.